Hello, today we will be teaching you about integration by parts. So integration by parts is a formula that is used to solve integrals that are more complex looking, such as the integral of x squared cosine of x dx. That cannot be solved in a normal way, and that might frighten you because you don't know how to solve it. But after this video, you will know how to solve it, because we will teach you how to use this formula, which is the integral of u dv equals u times v minus the integral of v du. This formula is used to solve all integration by parts problems. Now, the way you use it may vary, but it's always used, so keep that in mind. Don't try to use some other formula when you're doing integration by parts problems, because that will not work, generally. So, what you want to... Okay, for integrations by parts problems, they're usually comprised of these functions that I will write at the side, that are in a neat little acronym called LIATE, which stands for log, inverse trig, algebraic, trig, and exponential. And Michael will also reiterate this little acronym for you. So these functions are usually comprised, integration by parts problems are usually comprised of of two of these functions. Usually it's an algebraic and one of the others, or it's just two of the others, excluding an algebraic. These other ones that aren't algebraic are called transcendental, but you don't really need to know that. That's just a little neat fact that you can wow your friends with if you so desire. And basically, how to use this formula, it's not that hard, really. It just takes some practice. So what you want to do is you want to assign one of these functions to u and the other to dv. And then you integrate dv and you take the derivative of u to get du. And then you just plug things in and out pops your answer. And yeah, now we'll show you some examples of how all this works.
So now that you've learned why and where you use integration by parts, I'm going to show you how you do it. So I like to start by writing out LIATE, which is log, inverse trig, algebraic, trig, and exponential. So this is the order that you choose for your u term. So log would be like natural log of x, inverse trig would be inverse sine of x, algebraic would be x or x squared or 1 over x, trig would be sine of x, and exponential would be something like e to the x. So what you do is, let's say you want to integrate x e to the x. So now you look through this, log, don't have any logs, inverse trig, don't have any inverse trig, algebraic, oh, there it is. So then u equals x, du, so you just take the derivative of this, equals dx, and then dv is the other term, so dv is e to the x, and v is e to the x. So then you take this and you have uv, so x, e to the x, minus the integral of v du, so v e to the x du dx. So then you integrate this and you just get e to the x, so then x minus e to the x. So for another example, let's say you want to integrate, let's say x sine of x. So then for this one, same thing, log, no, inverse trig, no, algebraic, oh, you got x, so u equals x, du equals dx, dv equals the other one, which is sine of x, and then v, so when you take the derivative of sine of x, you get cosine, so when you integrate it, you get negative cosine of x. So then again, you have v, and then a u, minus the integral of v du. So now you have negative cosine x times x, and then these negatives cancel out, so then you just have plus sine of x. So for a third example, let's say you have x, natural log of x. So this one would be different because if you look log, oh look, I have a log. So if you do this and you set x equal to u, you don't know how to integrate natural log of x, or you probably don't. So we have to set natural log equal to u. So u equals natural log of x, du is 1 over x, dv equals x, v is x squared over 2. So then you have uv minus the integral of v du. So then when you get this, you have natural log of x times x squared over 2 minus, so this would be the same as the integral of x over 2. So natural log of x times x squared over 2, and then minus, so this is just, you can pull the constant out, and then you have x squared over 4.